Not every RF PCB should use one material throughout the entire board. In many real projects, the better solution is a hybrid RF stack-up. Rogers, TFE, and FR4 each have advantages, but when RF, digital, power, and cost requirements appear in the same design, one material may not solve everything. Many RF modules are no longer pure RF boards. They often include RF transmission pads, digital control circuits, power management, shielding, and connectors on the same PCB. A hybrid stack-up combines low-loss RF materials only where RF performance is critical, while using other materials for digital, power, or mechanical support layers. Engineers consider hybrid stack-ups when only part of the board needs low-loss RF performance, especially for controlled RF pads, antenna feeds, filters, or RF front-end sections. If the board also includes digital control, bias circuits, power routing, or communication interfaces, using premium RF laminate everywhere may not be practical or necessary. Hybrid stack-ups are often used to balance RF performance, manufacturing feasibility, and total project cost. Because yes, even excellent RF performance still has to survive purchasing. Humanity is tragic that way. But hybrid stack-ups also introduce manufacturing challenges, including different material expansion rates, lamination control, drilling behavior, and layer-to-layer registration. Before choosing a hybrid RF stack-up, engineers should review material compatibility, bonding system, impedance targets, via structures, thermal behavior, and manufacturability. Hybrid stack-ups are common in RF front-end modules, radar boards, SATCOM systems, wireless infrastructure, antenna feed networks, and RF test boards. Engineers should not choose hybrid stack-ups because they sound advanced. They choose them when the system needs both RF performance and practical manufacturability. If your RF PCB combines low-loss materials, FR4, TFE, Rogers, or mixed RF and digital layers, UltroNiu can help review the stack-up before prototype release.